Welcome back everyone to the last video of chapter 6 of trigonometry. 6.5 calculations with sines, cosines and tangents. This is just going to be sort of a summary of what you have done up until now, and we're going to ask the questions a bit more in so-called, what they say, story questions. You should solve these by first making a sketch of the situation to find a right angle triangle. And they're going to give you some kind of approach strategy guides, right? So if you get questions like this, understand the situation. And let's take a look at it later, what they mean with that. Make a sketch and find a right angle triangle, because this works in right angle triangles, right? If necessary, draw an auxiliary line segment, an outline. Use a trigonometric ratio to solve the problem. Do not round your results, but use the answer button on your calculator, because that doesn't round, right? Answer the question, check whether your answer is realistic, and write down the appropriate units. Again, this part you have to use a lot, right? So know the ratios. Let's take a look at some exercises. For example, and they're very funny, right? Oh, it's such a funny book. Mr. Angle is driving down a slope with a uniform grade of 18%. His odometer shows that he has covered 1600 meters. Calculate how many meters he descended. The first step was understanding what we're dealing with here. The first thing that I see is that they don't give us an actual angle of elevation. They give us a grade. 18%. So, I have to know how to now convert this grade to an incline, and from an incline to an actual angle, right? He is driving down a slope and he says that he has covered 1600 meters. Well, that's either going to be in hypotenuse, an adjacent, or an opposite side. And they want to know how much meters he has descended. Start by sketching this now. So make a sketch and draw a right angle triangle. Step 1 I just discussed a bit, right? Just read it carefully and know what they're talking about. Maybe be on the lookout for things that you should be worrying about. I think this is the sketch that they want you to make. If you go down, he covered 1600 meters. He has covered this side, right? The hypotenuse, actually. And which angle is now has a grade of 18%? Well, I think that's angle B in this case. If we now want to convert this to an actual angle, well, if our grade is 18%, that means the incline is 0.18, right? Divide this by 100%, you get 0.18. That means the tangent of angle B is 0.18. What you could do is take the inverse tangents, right? The inverse tangents lets you switch from an incline to an angle of elevation. If you see this, you can also say you take the inverse tangent on both sides of the equation, and the inverse tangent and the tangent, they cancel each other out, and here the inverse tangent of 0.18 you can calculate using your calculator is 10.2 ... That means that they don't round this yet. They say this is approximately your answer. Use your answer button later on in this question so you don't round anywhere. Now we know the actual angle of B, right? I know B. I know the hypotenuse. If I take a look from angle B, what is AC? Well, not the hypotenuse, because that's BC. So this is going to be either the adjacent or the opposite side. Well, I think this is the opposite side, right? I know the opposite side and I know the hypotenuse. I know O and H. Remember SOH katoa? I think here we're going to use the sine, because I know the opposite side, AC, divided by the hypotenuse, BC. The sine of angle B is AC divided by BC, so the sine of answer, that's this number you can say, right, approximately 10.2, equals AC, which you want to calculate, divided by hypotenuse, the slope is 1600. This is a number, sine 10.2 something. So AC is now sine of that number times 1600. This you practiced kind of a lot already. Is approximately, well, not even approximately, they say is 283.4 dot dot dot. Now we're not done yet. At 4, take a look at, is this reasonable? Well, it is reasonable because at least this is not longer than the hypotenuse, right? If one of your sides is longer than the hypotenuse, then you've done something wrong. What we should do is round, at least, and we should write down the actual units used here. And here they say round sensibly. If they don't say how to round, here I would just round on whole numbers. The nearest integer, right? If they don't say this and you would round to 283.4, I personally am more, my preference is that they just say to which, how many decimal numbers you should round. If they don't say that, then I think personally I would say that if you would answer that's 283.4 meters, I would count, not count it as a wrong answer. Do write down meters though. That's important. So step 1, understanding what this is, understanding what the grade is. Remember how to go back to the angle of elevation. Know that you after that sketch a thing like this, give the vertices, label them with letters, write down this thing in letters, start calculating. The most important thing is that you make a sketch first, I think. Otherwise, it's very difficult to make or calculate correctly here. Okay? And B, we will take a look at this kind of calculations in actual 3D figures. Maybe I'll see you in that video. Otherwise, good luck with doing the exercises of the projects.